Awesome. Yeah. Thank you. Thank you, Pradvi. Srinivas, you want to go next?
Yeah, hi all. Very good morning and good evening. Yeah, I'm from based out of Dallas. I'm working as a data engineer, so for T-Mobile.
Good. Sandeep.
Yeah. Hey everyone. My name is Sandeep. I'm working as a data engineer in T-Mobile. I live in Dallas, Frisco.
Awesome. Vinay, you want to go next?
Hey, hi everyone. Good morning. I'm Vinay Kumar. I'm working as a senior software test engineer in Dish Network. Um, I live in Dallas. That's the brief. Good to see you all. Let's
Okay.
explore AI together. Thank you.
Thank you, Vinay. We have next Lakshman Rao. Oh, sorry, Sangeet. Sangeet Raj.
Yeah, hi.
Hey.
Okay. Yeah, hi. I'm Sangeet. I'm from Manchester in UK. I'm data engineering manager in Asta, which is the equivalent of Walmart in US.
Oh, Asda. Yes, I know. That's nice. So, sure. All right. Great. Great, Sangeet. London. Awesome. Nice. Right. What's next? Missed the part here. Lakshman Rao. Yeah, you can go ahead. Lakshman.
Hi guys, good morning, good evening, wherever. I'm Lakshman, working for Walmart as a site reliability engineering team. Yeah, nice to see you all. Let's learn together and do some great POCs or projects in AI. Thanks, Madan.
Awesome. Yeah, awesome, Lakshman. Thank you. Thank you. Nitin Sangle.
Hey, hi. I myself Nitin Sangle. I'm working in a Dexter International as a platform engineer. I'm based out of Bangalore.
Awesome. Thank you.
Thank you.
Thank you. Bangalore. Okay. Yeah. Who else was that? Prashant? Did we already go? Prashant.
Yeah,
And
hi, I'm Prashant. I'm working for a company called Payment Assist as a data engineer. So I'm based out of London.
based out of
London.
London. Oh, awesome. Great. We have two people from UK. London. Okay, great. Awesome. Mayur.
Yes. Hey, hi. My name is Mayur, and I'm working as a DevOps and cloud engineer in Think2 INC.
Awesome. Where are you located, Mayur?
Pune.
Pune. Okay,
Yeah.
great. All right. Anand Raj. Anand might be on mute. Okay. Ramji, yeah, you can go next.
Hi, good morning and good evening, everyone. My name is Ram Kotipatrani. I'm located in Maryland, USA. I'm working as a data engineer from the past 5 years, and earlier developer role I have done. And most of the time, I'm working on the database processing and database engineering. This kind of, I'm very interested to learn the new concepts of AI engineering, particularly this LLM, RAG, and agentic AI. It is very mandatory at all the enterprise sectors. And nice to meet you all. Yeah.
Awesome. Shubham.
Hello.
Hey, hi, Shubham.
Hi, my name is Shubham. I am a data engineer and I have 5 years of experience. And yeah, I am also keen to learn the new concepts of AI. And because of the AI boom, I am also interested in working on the GenAI related things.
Awesome. Great. Did we go through everyone or anybody still want to talk, introduce?
Hey, Harun and everybody.
Harry.
Harry. Yeah. I'm Harry Pandey. I live in California here, working as a data engineer for a healthcare company. And yeah, similar, I'm just excited to. This is my second actually. I started the earlier session, unable to finish everything, and just wanted to again restart the class. So I'm
Yeah,
really
Hari
excited.
had to do some transition at his job, so he missed a few sessions. So he's joining back to repeat those sessions and consolidate his understanding. He has a goal to move into the become a GenAI engineer, GenAI architect kind of roles. Awesome, thank you, Hari. All right, so I think we have Girish here. Girish.
Hello.
Hey, good
My
morning.
name is Girish, and I live here in Dallas. I'm very, very excited about this session. I've missed a few sessions in my. This is my second time as well, similar to Hari, and I just want to catch up as well.
Great. I think we are missing people from Austin today. Dilkash and Ravi Naidu. I'm not sure. I thought Ravi joined for a bit and then kind of dropped off. Or, anyways, we'll check. Let me quickly. 1 second. Who else is there? Let me ping. All right, guys. Okay, great. So now let's jump in, get started. Let me share my screen. Okay, so all through we are doing this session, you are welcome to add your comments and you're welcome to add your comments and any questions. I'm happy to answer, but in the interest of the time, we'd like to keep it short during the session. But towards the end of the session, we can spend as much time we can based on the interest of the people and time. I'm open to extend the session and discuss few topics. So I hope everybody is okay with that. So let's start with introduction session today. So and as I said, we like this to be more interactive. Now, when you say GenAI or AI in general, what is the first thing that comes to your mind? Very common, synonymous, right? So when you say search, it's Google, right? So you say Google is search, synonymous now. Google is very synonymous with search engine right now. So whatever you do, you open the browser, you start with Google, correct? Earlier, instead of Google, we had Stack Overflow, we had a lot of other resources. I mean, with Google also. But when you say GenAI, what comes to your mind first?
ChatGPT.
ChatGPT. Awesome. Great. So what do you understand about ChatGPT?
Yeah, whatever we ask the question, instead of giving the links as suggestions, it will give the precise answer. So most of the time, that will be enough for us to get a clarity on that. So when you in Google, when you search it, you need to open the multiple tabs and you need to grab the information.
Right. Okay. So when we talk about GenAI, we just talk about we kind of connect with ChatGPT, right? So it's kind of become synonymous. ChatGPT is a GenAI application. Okay. So it is generative in nature. Not like Google. So the basic difference between Google and any LLM is Google will scrape all the data on the internet and has search for the keywords, bring in all the URLs or links, then re-rank it based on how prioritize, and then give you all the answers. Generative is completely different. It's a language processing tool, or the platform to technology, whatever you want to call, where it understands your language, it understands the context, it has already the knowledge it has been trained on. Okay, the entire open source available information has been fed into the models, what you call in GenAI, and it can understand your question and answer. It can generate an answer. Okay, it's not showing you, hey, go here, there is some document here, go here, there is some report here, there is a blog here, you go and check if that helps you. That's what is the Google does. What a LLM model, a GenAI application does, chat model does is, your question, it generates the answer based on the knowledge it already has, it has been trained on. Okay, so that's the basic difference between these two. Now, GenAI is not all ChatGPT. Okay, so ChatGPT, just like we thought about search engine, is Google is not just a search engine. Okay, ChatGPT is just an application which sits on top of the LLMs, which we call like large language models, which are the brain of all the GenAI, this entire evolution of GenAI. Okay, so the ChatGPT, so that's the basic difference. Now, ChatGPT is only one part of the entire GenAI, and it's just an application, not a LLM in itself. And when you do run ChatGPT, you ask any question, the underlying engine that runs and answers is a LLM model. Okay, so that's about what is the basic difference, right? Now, today we'll talk about how the GenAI evolution. So again, as I was saying, I'm more of hands-on experienced guy. So we'll just have to go through some of the concepts first, understand what each of these components are, so that when we go ahead and talk about deeper and then start using them, there is no confusion of what is ChatGPT and what is an LLM. Okay. We have to very basic foundation concepts have to be very clear of what we are talking about. So today we'll talk about all the concepts. We'll go through what is evolution of Gen. Again, very brief. I'm not going into deeper theory and papers and all of that. I'll just give some reference. But then what are the use cases? We all know most of the use cases we know. We can also talk about any use cases you are working on. So what are the types? What is an LLM? What are the different types of LLMs? Who are the providers of those LLMs, and how what are the components of LLM? Then somebody talked about building RAG, building agentic AI. So what are these architectures at high level? So we'll discuss all the concepts today. Tomorrow we will be getting into the prompt engineering, how you interact, how you talk to these LLMs. Okay, so that's this week. Now, as we go more and more deeper into the training course, or the next week, we'll start introducing all the demos codes next week. So today also we'll look at some of the models, talk to some of the models, and see the capabilities kind of thing. Okay, so evolution of AI to GenAI. So when you see mostly at a higher level, it's all part of the AI. So when AI early 70s, 60s, or before that 1970s, 60s, when we all started, machines mimicking human task. Any machine just which is not a human doing some work based on some instructions was coined the term as artificial intelligence. It may not have intelligence at that point of time. It might be just a repetitive task, but that's the term that was coined as artificial intelligence, that encompasses all of the evolution of different era from that point. Inside that, you have machine learning. So once the AI, it's like kind of building, robots or basic computers. Everything was called under a big umbrella of AI, right? So the next evolution was the machine learning algorithms that learn from data. So we all know what are the machine learning algorithm. What is machine learning? Basically, is you give some historical data and train some model. Hey, this is the pattern. This is how it looks like. If this is all the input, this is how the output looks like. And then you use that model for a new data that is coming in to classify or predict based on the historical data you have given it the training on. It's very basic. Any model. So models, all of these models training, right? It's very simple. That's just like baby. When a newborn baby or a toddler, you start teaching the baby, right? They don't know how to do any task or what to do. So you kind of explain it to them how to do anything, right? Eating, basic, walking, all of that. And then you also show examples. Hey, this is how you have to do this. This is how it has to do this. So when a new scenario comes in, right, they would naturally act based on the training that you have given. This is the same for pets. So there's a pet training that you do, right, to teach them all the basics of hygiene, basics of eating, basics of security training, protection, all of that. The same thing with the models. You train them on certain scenarios or certain data. You label the data, and then when you run, you come out and say, hey, this is the output based on this data. If the data looks like this, 1, 2, 3, 4, 10, these are the outputs, 1, 2, 3, 4, 10. Now I have at 11th one. Say, for example, I have patient data for cancer or cancer patients. Now I will take all the data of that patient saying that, or the cancer cell saying that how it looked like, how much it weighed, on which date, and what is the image, any properties, all of that. And then we say this patient was diagnosed, or this tumor was diagnosed as malign, malicious or benign, right? So that thing. So you take like thousands, hundreds of thousands of data from the patients to train on the model. And then when you have a new patient that is coming in, you're doing a new analysis of the same, say, some tumor. You can feed the same attributes of that tumor to the model, and then it can categorize whether it is a malicious or benign cell, cancer cell, basically based on all the previous data that it has seen and learned from the features of how it looked like each of them, and then came. Same thing for images, say X-rays or MRI scans. So all of these you can train the models on, and then say predict or classify the new data based on the historical training that they have. So that's the any basic for an ML model, deep learning or GenAI. That's the basic, right? So that machine learning has evolved, and from there it came DL, neural networks, where not just through the historical data, but it got advanced just like the neural network, where you add weights and biases at every layer of, and then you go deep learning. You split the input into the pixels or smaller dimensions, and you attach weights and biases. You go layer by layer. That's like training, say, image recognition is one example of the deep learning. You give an example of a cat, classify that, and then you give a picture of dog. It goes through each layer by layer, and it comes out. It can classify the output whether it is a cat or a dog based on all the images it has seen. It's basically same kind of training, but it has models and weights. It goes through each layer, adding and removing biases and weights, and then a final output to compare with the original and come out with what is the picture. That's what is it's used in any of you do the security, right? You want to capture image. How do you recognize that? There's several kind of, again, comparison of X-ray images, from the historical, does it look like this? Then the good one and the bad one, compare the new one and decide whether it has some issue based on the historical images, or it's all okay, kind of a thing. From there, then we started. There was a paper called "Attention is All You Need" from Google in 2000, early sometime around 2010 or so, 17, I guess, where from DL it became NLP, right? Natural language processing. So how to process the natural language and understand the context and the instructions from there instead of the programming commands, basically. And then it convert internally and do what you want to do. So on that NLP basis, the focus was shifted to how a model can read in parallel all the words and sentences and process it together rather than in sequence, word by word. So that is the very high basic premise of attention is all you need. You can look at that paper. That is the basis of all of these new models, GenAI models that have come in, the newer models, better models that are coming in, that are being trained. Attention is all you need. So that's a transformer model that works on, it takes the current token, processes it, and then it predicts with different probabilities what can be the next token based on various so many inputs or so many sentences or scenarios it has already gone through, read and understood. Based on that, it will try to predict the new token. So NLP models, at least the text models, all work based on predicting and generating the next token, because it's generative in nature. It just keeps on generating next token, next token, next token, and that's how it kind of starts writing the answer. When you, even if you see in ChatGPT, each token is generated, then the whole context is reread, and then try to predict in this context what could be the next token, what is the highest probability, and then pick that word and start building that. So that's how the models start building using the generative technique, right? So that's predicting the next token. We used to recognize cats, but now we generate them. So when you say deep learning, it was used to identify, recognize pictures when you give them. But GenAI, you can generate a picture altogether, new picture, right? So it's now the generative in nature. So GenAI basically can create the content generation. It can be text, it can be images, it can be code or whatever. So this is the 4 phases that we talked about, where we have came to the evolution of generative AI from early artificial intelligence AI systems based on logic and rules. So if this is this, you do this. It's kind of branches, effects, conditions, logics, and rules. First attempts at understanding the language. ML models are more statistics, probability, where you build statistical models, pattern recognition, and then you have supervised, unsupervised learning, neural networks, then form the basis of deep learning. So you have some generative models, NLP advancements that came in with deep learning, where artificial neural networks, ANNs, were coming in. Basically, it's all different algorithm that you use for image recognition or any of these learning models. And finally, we came into the generative AI models like GPT, BERT, all of these based on what we said, transformers model. Okay, so this is the from left to right, from 1950s, 60s to about 2022 is the model 3.5 or something that came in. That was the turning point, or we can say pivot in the AI, GenAI history, where ChatGPT, blown all of us with the capabilities. So now so any questions till now? I know this is all very theory, but just trying to understand where GenAI fits in the overall umbrella. So it all encompasses. GenAI is a part of deep learning, which is part of machine learning, which is part of artificial intelligence. Underlying generative AI, these models also use deep learning and machine learning as well. They've been trained on. And again, they trained on massive amount of data already. Okay, so just another quick peek before we deep dive into the GenAI itself. It's a focus. So what we looked at, the machine learning. So the difference between, because why I'm only stressing on ML is here, a lot of job descriptions when they do GenAI, they also add a machine learning component, ML component as well. So the use cases are different, but generally by kind of association or by kind of confusion, they go hand in hand together. Most of the places they also mention hands-on machine learning, ML, and then GenAI kind of a thing. Okay, so they also put deep learning as well, but that's okay. But at least ML models, you should have some understanding high level what it does. And that just because to differentiate between what kind of use cases are fit for a machine learning model, what kind of use cases would go into the GenAI models, right? So machine learning is, as I said, basically you give a lot of historical data, you label them, and then you train the model, any of the models. So you have different models, that libraries that we have, like XGBoost, PyTorch. So there are some few models that are available that you use, and then process your existing historical data, training data, and then give some test data and see how it performs on the actual test data. So when the model is tuned and you have giving, say, for example, prediction correctly or classification correctly, then you give it any new information that comes in, you feed in through your ML model and get the outputs. So classic example, let's say, is credit card transactions. Okay. Let's say you are using your credit card in California, and then let's say within 5 minutes you are using your credit card somewhere from New York. So that should flag a fraud, right? So you cannot be in two places, unless you are in quantum, basically, to use the card, or you might be using online or something, or even something is wrong with that. So how do you flag that kind of transaction? Is you process, each transaction is going through your machine learning model. When you swipe it, it goes through all of the ML models. It goes through your ML model process, and then it classifies whether it is safe or fraud detection. So that is one kind of use case, let's say, for example, for the machine learning. But here in machine learning, you have supervised and unsupervised learning. And then, yes, there is a reinforcement learning based on the output. The supervised learning, again, is regression and classification. So as I said, fraud detection, customer retention, diagnostics. So that kind of regression is there, in which you can also do a prediction, linear regression. So if you have historical, for example, the prices of real estate, say houses you have, and then you want to predict a price for a particular home or particular location, so you can use regression model. Classification, basically you want to classify for marketing purposes, high income group, low income group, or likely potential based on customer demographic, right, and income. All of these features you predict, hey, this you classify, hey, whether this customer can do this or cannot do this. Okay. And then clustering algorithm is what you use to make different clusters for the marketing. So classification basically will tell you it's a binary, just like we were talking about earlier, the cancer cell. It will say whether it is a benign or malicious. Yes, no, it can classify. It's binary kind of a thing, true or false kind of thing. Churn management, whether the customer will stay or will leave. So those kind of classification that you would do in the supervised learning. Supervised learning basically will give you, because you have earlier data clearly labeled. If the customer has these attributes, the output was he has left. Or if customer has these attributes, he has stayed. So based on the already available input and output data, it is trained. So that is it, supervised. Unsupervised is you don't have an output. You just let the model decide. Customer segmentation, as I was saying, if you have different clusters, you want to divide the customers based on their geography, age, income, whatever, how many clusters you want to define and label them for marketing purposes. And then you also have recommendation engines. Basically, if you see Netflix or if you go to any online portals, so based on your purchase history or based on your browsing history, they're going to recommend products. Even Netflix, based on what you have viewed, they're going to they're going to recommend you, hey, based on what you watched, we feel this is what you might like for each genre, based on the genre. So those are again machine learning based on the recommendation models that you use. And for gaming and real-time decisions, robots, that is reinforcement learning based on the action the model has taken, what was the output, and it works on rewards and benefits. So whether it is rewarded or penalized. So based on that, it will learn. So next time, you're not going to take that path of decision making. Okay. So this is mostly used in the gaming and robot navigation and all of that reinforcement learning. So these are high level. When you talk about machine learning, these are classification, regression. So basically they fall into three categories: supervised, unsupervised, and reinforcement learning. In supervised, you have regression, classification, and also recommendation. In unsupervised, okay, recommendation comes under unsupervised. So unsupervised, you have clustering, dimensionality, and your recommendation. And then reinforcement is basically your gaming, robot, and all of that. Again, this is all just for understanding, to have some knowledge of what models are. Within the regression and classification, then if you go and see, you can see what are the algorithms. And so these are all like algorithms. What are the libraries that you want to use? PyTorch, scikit-learn, XGBoost. There are a lot of these libraries. And then algorithms are also there. Random forest, regression, linear regression. So there are different algorithms and libraries that are used for these models. So that's again a huge topic. You can, if you, for your own interest, you can explore and read, but at the high level, this is where you just want to focus in each of these to at least talk about in any interviews and explain, hey, yes, these are the models and these are the categories, and this is the use case that we have worked on and built, say, let's say a regression, demand forecast. Very basic use case all the companies have is demand forecast. Even at the simplest thing, like say if you have a Walmart or Costco, whatever it is, demand forecast is very important, especially in terms of, say, perishables, like vegetables or fruits or meat. How much meat you want to stock for based on the season, whether it is summer, winter, location where it is, what is the time of the year, what are the temperatures around, weather conditions. So you, based on all 15, 20 parameters, you have to predict how much you want to stock for a particular store. That's the demand forecast, so that you reduce the items, perishable items. Okay, so freezer items are to some extent okay, like meat, but let's say the fruits, right? So they go bad, or vegetables, they go bad very, very quickly. So Demand forecasting is very important. That's a very simple use case that you can talk about using the machine learning model. How do you have implemented for things like T-Mobile, whereas on the mobile, the example I'm just giving, any of these, the most common use case is your churn management. Hey, based on this customer pattern, will he stay or will he move out of the your membership? Or he'll be a customer or he'll move out to another provider. Okay. Recommendation, again, if you are in retail or if you are in online, anything, so you base target marketing based on what they have purchased or browsed. No matter where you go, you keep seeing only those ads, targeted marketing, right? So that's where you do clustering and recommendation, basically. Once you view some product, that's it. Everywhere you go, only the similar products pop up, right? So that's targeted marketing based on your behavior, the recommendation engine that runs. So these are the some basic examples. Now, jumping onto the GenAI. Any questions before we move forward? I know, as I'm again reiterating, don't get overwhelmed or too much about what we are talking. This is all just for setting the tone for what we are going to learn, just to have some knowledge, understanding, and at least talk about, differentiate between what is ML and GenAI. ML is not GenAI. So that you have to be at least very clear about. Or for that matter, deep learning. It's different. Any questions?
Maybe, Harun, it would help if you can highlight, what were the shortcomings in one of those things? Like, I know it's a broader umbrella, right? So what were the shortcomings that led to the, ML ops, ML, not ops, ML evolving to deep learning and then deep learning evolving to the GenAI models, right?
Yeah. So machine learning, so as we looked at, right, it's a logical evolution, basically. So machine learning are more statistical models. If you look at so ML was specifically for these kind of probability and statistics where you want to predict or classify some of the inputs based on the historical data. That's what was. It's more the statistics and probability that was going in. But deep learning was more on understanding the context, or not even the context, the image recognition. Basically, how do you make something, giving it some intelligence to make decisions, to understand, hey, this is what it might look like, the picture of a cat or picture of it, or the training on the image recognition and decision making. That was the next step, logical step. GenAI was more as a natural language processing, where you have to understand the context and generate something. So language is human language, like how do you understand a human language and then act upon it and generate the content. So generative nature. So underlying, again, as I said, for parts, it might use some of the deep learning, some of the machine learning models that it has already. And then based on that, it is trained. That's why the LLM models are very expensive to train or to create, right? So runs for millions of dollars because they need extensive training about the GPUs that you need to train. So that's how the evolution, it's the logical evolution that happened. If you have any other examples you can share, can relate to the use cases, basically. So use cases we talked about, right? So we talked about where machine learning use cases are, and when we move forward with the AI, GenAI, we'll talk about in the next slides, we'll talk about what are the use cases that GenAI is. We touched upon a little bit, but yeah, I can talk about. We can bring in more use cases in each category we can talk about. So let's take that as action item, then we'll figure out, and then we'll come back. We'll discuss more about which use cases fit in each of these categories during the evolution. Okay. Now, when we talk about, so I think we already touched upon generative AI. It's more creates new content such as text, images, music, and code based on your input prompts. So prompt is basically how you give your commands. Just say for any programming language or operating systems, you go to terminal and start you typing commands for the system to do something. The same communication with a model, LLM model, is done through input prompts. That's why the whole term called prompt engineering has come in. We'll talk about more prompts tomorrow. Unlike traditional models that focus on classification or prediction, GenAI generates novel outputs using techniques like transformers and generative adversarial networks. So these are all again evolved from deep learning, but it is evolved into the next to predict and generate the content, not just classify or a numerical prediction or numbers or binary. It starts generating the content instead of image recognition. Now it can create image, text, audio, video, everything can be generated using GenAI. That's the differentiation between the traditional AI models or ML models to the GenAI. So we talked about attention is all you need. Yes, sir. 2017. It talks about all of these large scale models, generative pre-trained transformer. That's what it stands for. GPT, which falls under which is used for in the OpenAI. All their models are called GPT models, and that's where the Chat GPT has come from. So basically, the model created by OpenAI company is called named after GPT. That's the model that they have, generative pre-trained transformer, and that's used in the application. So that where Chat GPT came in. There are different models that we have: bidirectional encoder, representations, and transformer. This is all the underlying tech that goes behind in the LLMs. That's a different topic altogether to dig deeper. But these are based on, all these models are based on these underlying models too that work. Basically, the GPT models and the BERT are used for all of these LLMs, under the LLMs to build these LLMs basically. Okay, so that's the basic differentiation. Now, what exactly is a LLM? Large language model. So it's pre-trained on massive text data sets. Massive text data basically is all the available information which is public, has been used to train these models. Okay, what are the examples of LLMs? So GPT-4, now it is GPT-5 latest. So some of these, whatever in the deck might be old references. There might be latest things that have been changed. So GPT-4 to GPT-5. Claude is one model, Palm is one model, Llama is one model. There are so many of them. We'll see how they are categorized. What are the capabilities? Again, capabilities categorized based on capabilities as well. Multi-model can chat, summarize, code generation, image generation, audio generation, video generation, all of that. What are the limitations of LLMs? We'll also talk very in detail what are the limitations and why that RAG architecture has come in, because the hallucinations and lack of citations is one limitation, but then there are two main limitations that LLMs have. One is the cutoff date for the knowledge. Basically, when we said it is trained on massive data sets, any model that is released already, let's say GPT-5 is already released model, whenever that is released in 2025, January, let's say, for example, it will have knowledge only up to the available information to January 25. Any event or any information or any content that is there after January, it does not know. It's not been trained on. So it cannot answer if you ask questions directly about current event. If you ask it what is the weather today in Dallas, it cannot answer. If you ask what is the weather in general in Dallas during March any year, that kind of generic questions, it can answer. Now you can say, hey, no, I can ask ChatGPT, it will answer me even weather today. That's different because ChatGPT is not a LLM in itself, as I said. It's an application that's built on the underlying LLM. You have the engine as an LLM. We'll see how an LLM on itself is different from the ChatGPT application. Okay, so if you just say LLM, it cannot answer what is happening currently. That's one major limitation. The other one is it does not have information about your own organization or your personal information of your company to answer any questions. Obviously, because you would not have exposed it as a public data, right? So since that data is not available, that model is not trained on that data. You don't want to, basically. It's your company private information. But if you want to ask any question based on your company information, let's say, hey, what is the maternity leave policy? You want policy for your organization, not in general. What is the last quarter results or profit and loss for the last quarter for this US region? That's again depends on your financial data, what you want to expose. So the LLMs don't have that information, so they cannot answer. To overcome these, we have the new architectures have come called RAG, Retrieval Augmented Generation, to do a specific task to connect to the latest internet and then run complete orchestration, complete tasks in a sequence or in parallel, the entirety of it. We have agentic AI agents that have come in to solve the problems by collaborating and solving the entire problem statement. Okay, so those are the two main limitations. Of course, others we have hallucination and citations. Hallucinations because these models generally, so when you use Google, you are 100% sure that the result is, it's because it's not giving you any answer, it's just giving you a resource. You click it, you go there and then read, and you make your own decision as to, hey, this is the answer. You make up your answer based on the information. On the other hand, the LLM is already reading that for you or has that knowledge, and it tries to give out directly the answer you need, which means sometimes the answer could be wrong. So the LLMs, if they don't know the answer, sometimes they try to make up their own answer, which may not be factually correct. So that is called hallucination. Hallucination means an LLM which gives you a response even though it does not have that knowledge or it's not factually correct. And it does not give you citations. But again, these are the original limitations. If you go ask ChatGPT right now, it has capability to also give citations where it is getting information from. Second, it also has information about, you can ask the model to generate a citation where it is getting that information from. But basically, so these are the original limitations that it has. Somebody has asked a question about tasks. Who's that? One second. Can you come again? Some question I have seen the chat. One second. For all tasks, LLMs are different. Nitin. Okay.
Yes, yeah. Underlying the LLM or configuration are the same or like all are different? That's what my question is. I'm audible?
Yeah. Come again, sorry.
So all the tasks whatever the LLMs, right? Behind that, there are some models like BERT or something, GPT, right? Are all the same or all the different, respectively?
I will rephrase that question. Task, LLM, and models, these are all different things, right?
I
So
think
we'll have to
every LLM
understand.
will be capable to do all the tasks, or do we have a separate LLMs for each and every task, like weather forecasting, like some other?
Yeah. So as I said, based on the capabilities, there are different types of LLM models. As I said, text generation models can only do text generation. There are some models which can do image generation. So they can do both text and image, both generation. Some models can generate audio from text to audio. Some models can do the reverse. They can take an image and generate the text, the description of the image. Some models can generate the video from text. Some can generate video from image. They take an image and then generate a video with that. So each model has, as I said, specific capabilities they're trained on. So based on that, they are classified. So we'll see what models have what capabilities, and then you use for that particular use case. Okay, so example models, if you see here, the same task, right? Q&A. The model is GPT-4, Claude, PaLM 2, Llama 2, DeepSeek, Grok, Gemini. There are a lot of hundreds, thousands of models, LLM models that do text generation, the Q&A kind of a thing. Just, text, answer, question and answer kind of a thing. Text to image, you have DALI, Stable Diffusion, Midjourney. These are all the different models. These are different companies that have models, specialized models to generate an image based on your text. You give a prompt, it generates an image. Of course, ChatGPT also does that. We have already seen all of that. The Ghibli trend or different different trends and styles that have come in generation of image. Originally, these were like more sophisticated or specialized niche models that they were doing text to image. Now all other models have become multi-model. They have capabilities to do that. Text to audio is basically you write a text and then it reads out. You have seen that applications many in videos where the voiceover is there. You just give the text and it reads that text, converts it into audio. So these are kind of some models that use text to video. Again, Runway ML, Pika Labs, Imagine from Google. Google has new Veo, a lot of new models that are Sora from OpenAI. So a lot of these models is you write the prompt, it creates a video. So you can write a prompt, you can write a paragraph, you can write a story, you can shoot the entire short film just by giving description of your prompt or story, and then it will generate the entire video, the entire short film. You can do just by giving the text to video models. So as I said, yes, each model has a specific capability, I would call, rather than task, the capabilities. Some of them are multi-model. They can do more than one. Language, for example, some models can do in English. Some models can do 5 to 10 languages. They can generate, understand, and generate in different languages as well. Translation is one of the use case from one language to other. It was already there for so many decades. Language conversion. Google Translator was one of the original ones, but it was more not generative in nature, more conversion kind of a thing. But now you have more sophisticated and advanced, translation, multi-language that you have based on all of these models. Does that answer your question?
Yes.
Yeah.
And one more question is that, so on a ChatGPT, when you type a question, right, so it will decide which LLM based on the question, right? So
no, so we'll see that. Okay, we'll come there. I will show you. If you see here, the company, if you say chat GPT, there is no chat GPT here. As I said, you have to clearly, the first thing I'm only expecting out of this session is for you guys to understand what is an LLM, what is an application, what is the provider, what is the platform. Just these components, because a lot of people get mixed up in these things. This is the basic. As I said, chat GPT is not a model. There is OpenAI, there is chat GPT, there is GPT-5, right? So how these are all different, how are they connected is what I want you guys, that's the main outcome that I'm looking at from this session. If you look at the companies, the providers who are building the models and who are giving you know already, right? So Google has built some models. Google's set of models are called Gemini. There are Gemini, in the Gemini series, you have multiple models. And then there is Palm 1, Palm 2, there are a lot of things. We'll go dig deeper on this, these things. So Google is the provider, okay, company that provides LLM models. Anthropic is another company that provides models, and its models are called Claude. Claude 1, 2, 3 series, Haiku, Sonnet. There are so many models Anthropic has. Meta is a company, we know. And their models are called Llama, Meta Llama models. There are so many of them. Amazon has its own models called Titan series. Titan Nova, Titan Text, Titan Embedding, a lot of. XAI, basically Elon Musk company, their series of models are called Grok. Grok 1, Grok 1.5, and all of this. So this is the company, this is the model. Now, if we go back, each of these models can have capabilities of Q&A or text to image, text to audio, text to video, whatever. So there is a company, there is a model, and the model has capability. Now, when you are using any of these models to build something, that is your application. Okay, so chat GPT is a chat bot. That's a chat application. It's just like any company earlier used to have, you want to chat with support. It's the same thing chat GPT is. It's just a chat bot. It's an application. Now the question is, based on the question, can it switch models? No. Now we want to take a pause here and then go. Let's go to, now we understand. So these are the companies and these are the models, right? So first we want to, let's say, go to chat GPT itself. Okay, so this is the chat GPT. Now if you see here, these are the models. GPT-5 is the model that it is using. You can see here legacy models, there is a GPT-4o. Okay. Now you can switch models here before you ask a question, and then it will use that model to answer your question. It does not switch on its own based on the question. You have a model that you are using for your application now. So I want to answer this question with 4o. There is something called 4o mini, 3 legacy systems. Or you want, let's see here, decides how long to think. These are all features of ChatGPT 5. So you can just use ChatGPT 5. Okay. And now you can ask a question. It will use GPT-5 to answer. Right? So now, if I go to OpenAI, so we said ChatGPT or GPT models are from OpenAI, right? So if you go here, you see the models from OpenAI starting from earlier. GPT 1, 2, 3, they have removed all of that. It's very old. But at least you can see here 4o mini, 4o, OpenAI O4 mini, O3, GPT-5. So these are all, and Sora. These are all the models from OpenAI. Then you can go and see pricing. So that will come differently, how you want to use the models. Are they free? Each model, you have a pricing, you want to use OpenAI models. Once you subscribe to OpenAI, you can switch and use any of their models, but the pricing will be dependent on what model you are using within the and how much input and output you are getting. So that's a different thing that we'll talk about. So at least now you understand. So this is the OpenAI is a company that is providing or building models and selling models. Say, for example, subscription based or enterprise license. You take license from OpenAI. All of these models are available for you. You can use in whatever application you want to use. That's the model. Now, OpenAI itself has its own application built called ChatGPT. And we have seen, right? So this is ChatGPT, and you can use some of the models here. And then you also have something called Sora for a model. Okay, so you can go and see Sora. If you see features, this model, the features is bring your imagination to life with text, image, or video. So basically, this model can take in your text or image and generate videos like this. Open large doors into library, replace doors with French doors, turn the library into spaceship, remove the spaceship, add a jungle. So you can keep giving prompts. It will keep regenerating the views or the videos based on what you are giving the prompts. So this is a text to video kind of model, Sora. And Sora is from OpenAI. Okay, so did you get that connection now? What is a model? What is a provider? What is application? Now let's go same thing. OpenAI will go to Google. So Google has its own models. Okay, it has its own Vertex Studio where you can build GenAI applications. We'll come to that later. But if you see here, Model Garden, if you go to Model Garden, it will give you all the models that Google has. But again, the next level of servicing here is the model can be my own or the model can be somebody else, but I am providing service. Say, for example, a T-Mobile. If I can go to Apple Store and buy my iPhone, I can go to Samsung Store and buy a Samsung phone. Okay. Or I can go to T-Mobile. T-Mobile can sell both Apple and Samsung phones in their shop. Right. So same thing here. Google has their own models. Plus, it has models from other providers where they hosted it and they are providing services for those models as well from other companies. Okay. Let's see here. If I go here, Google models, there are 101 total. Okay. Partner models are 63. So if I click on partner models, filters. See, if you go here, in partner models, you can see Claude. Remember who's Claude from? Which company is providing Claude model?
Amazon.
Sorry?
Anthropic, sir.
Anthropic, right? So here, this is Anthropic. You can actually go to Anthropic site, Anthropic, and then directly have a contract with them, buy from them directly, create an account or a license, subscription, and use it. Or you can come to Google. Within the Google itself, you can say, hey, I want to use Claude from Google platform. Fine, you can use it here as well. So this is all hosted. These are called hosted models. Now Google is hosting Anthropic's models on their platform. Plus, they already have the Google models. You know what Google models are, right? Gemini models we talked about. So Google has Gemini, all of these Gemini models. Each model is again has specific features. Strongest model qualities, code and complex programs is 2.5 Pro. Okay, for code and complex pro. This is light balance Gemini model for low latency use cases. It's a very lightweight kind of a thing. You get immediate response. For complex ones, it might take some time, but this is specific code and especially for code and complex, you can use this model. Reasoning and speed 2.5. So there are so many 1.5 Pro created from the ground up to be multi-model. Text, images, videos is this one. So Imagine is basically the latest one. Use text prompts to generate novel images. So basically this is a text to image model from Google, right? Gen 4 fast for image these are all image generation. Okay, these are like versions of it, older, newer, 1.0, 2.0, 3.0. So they get each and one new version they release within the same model capabilities. Embeddings we'll talk about next week. What is embedding? Why we should use embedding in the RAG architecture and all of that. So basically, yeah, these are all the models from Google, Google's own models. Code Gemma, Virtual Try-on, Imagine. If you look at here, MedSig LP here, these are called domain specific. We'll come into the next slides where we talk about what is domain specific LLMs. But you understand this, right? These are all Google's models. And then if you go to partner models, you have models from basically Anthropic. Meta, Llama is there. This is from Meta, right? Same thing, Meta is hosted on Google. You can use these models. Mistral, this is another company, Mistral. You can use these Mistral models from Mistral. DeepSeek is there. Quen, NVIDIA. So all of these models are also hosted. You can use from Google. Okay. Sora is as a video. So Midway, Runway, what do you want to generate? So basically start generating with simple conversation. This is company called Runway ML to generate ideas, right? I don't know if you have to buy this or if it is free. Okay. Make an add photo for AI learning platform. Oh, it's a GenAI learning platform. It's asking for login or sign up. That's fine. We'll just see. Now, if you see here, this is from Midjourney. Okay, these are all the videos. Now, if you just click and see, again, you need subscription for getting all of this, login and buy and all of that. But you see here, this is the prompt that was used to generate this video. High angle earth zoom out point of view of a cute woman reaching down with roses against blue sky, flower petals blow past lens. So all of you're describing what you want to see in the video, and based on this text, it generates the video. If you see here, this is the text, nice gentleman, a long coat. So these are the specific models that you can write, modern woman living natural sunlight. So these are the ones that you can use to generate videos. So as more and more text you add, more and more description you add, it can create, just like we have already done with ChatGPT, all of that, right? Creating images that you can do. Let's say I want to go here and say, create image of lion with wings. Takes some time will come here. Okay, so that is the Google. We looked at what are the models that Google hosts, what are the models OpenAI has. Similarly, all companies have their own models. Is that clear?
Yeah. Harun, I have a question here. If you
Yeah.
go to this ChatGPT, right? Sorry, the open or ChatGPT page, right?
Yeah.
Over there we see, they have GPTs, right? Both custom built by the partners and also by the ChatGPT team. These are applications, right? So ChatGPT hosts applications from others. And is it right to say then that that's the
No,
difference between
ChatGPT does not host. See, ChatGPT is an application. You can only use OpenAI models in ChatGPT.
No, if you go to, let's go ChatGPT and take out the overview, go to the home page. Go to the home page of ChatGPT, not the overview, just chatgpt.com. Yeah.
Yeah.
And on your left-hand side, there is that thing. Yeah.
No, it's just a chat.
No, okay. So mine is
OpenAI. OpenAI.
no, you should have this sidebar, right?
Sidebar is here. If you go to ChatGPT application,
Yeah. So if you see the sidebars, right, and there you see Codex, Soda, and below are GPTs, right? And here you find all the GPTs from the partners as well as from their ChatGPT team. So these are applications, right? These are not based foundational models. And
this
for
DAL-E,
Gemini,
right? Yes. So these are DAL-E is from different
yeah. So
applications. So you
these are not foundational models. These are more applications. While what Gemini hosts is mainly foundational model, and then they don't host applications, right? Is that right to say, or is it different?
Yeah. So these are like your app store.
Yeah, that's what I was doing. Okay.
Yeah. So these are not OpenAI. These are not from OpenAI. It's just like you can buy and then use it here along with ChatGPT application. This is basically Log PDS. It's a marketplace, for example.
Yeah.
Right.
And these
So
are
they are
using
just giving you some posted marketplace where you can buy these from here. It's just a facilitating and then start using it here, but it's not part of the OpenAI.
And these are using the foundational model from OpenAI, or they could use other.
They could use their own. It's
Okay.
not necessary that they are using OpenAI. So DAL-E is much before the OpenAI. These are different what you call the deep learning models that were there even before GPTs had the capability for image generation and video generation. So before ChatGPT also, as I said, there were different models for audio and video, basically DALL-E, Runway ML, Midjourney. These were more popular than OpenAI models specifically for image and video generation. So later those capabilities were added to the OpenAI GPT models.
Makes sense.
So this is more like your marketplace.
Yeah. Okay.
Yeah,
And if you go to the Gemini, right? So we have the base foundational models, like I don't know, 60 plus from Google, right? And then there are some which are more like task oriented, right? So you see below we have task, object detection, image segmentation. Are the difference between the performance or is the difference between the price? I mean, why would not I use Gemini 1.5 for everything? and why use object detection? Is it more like that object detection one performs better, or is it the pricing?
Each model has some specific features what it's trained on, right? So if you want to do, it's basically the specialization I talked about earlier, right? So when you choose a model, there are a lot of features that you want to evaluate. What is the size of the model, complexity, how much time it would take to respond? If it is do we need a light version or a complex version based on our task? If you want to do mine, say, let's say I'm running a marketing ad agency. Okay. I don't need GPT-5 or GPT-4 text because mostly I will be on the creative side. Or say, for example, code generation model. I don't need a code generation model because I'm more on the creative side. I need the best product that can generate videos, add videos based on the content generation. Now, if I see in that space what are the best, then I can say Sora is there, Runway ML is there, or any other video generation, Veo, Google's Veo is there. So I go through them and then see which one is fit based on the price, usage, simplicity, complexity, and for my organization. If my organization already has Google platform, they make sense for me to use which is already available because it's easier to integrate and easier to use, and I don't have to take another new license, and all my data is already there, kind of a thing. That's one. Or if I'm a small organization, hey, I don't want to get into Google and then Veo models, it's expensive. I'd go for a very small player who can give me what I need. So it's all like your business requirements, and you evaluate based on some parameters. Based on that, you choose which model I want to use. Okay. Any product you want to buy, you evaluate 3 or 4. Even if you want to buy a phone, you can buy iPhone, you can buy Samsung, you can buy LG, whatever, different phones. A TV you want to buy, you evaluate different models. So there is some kind of brand affinity that you have. TV, I always buy Samsung. Phone, I always buy Apple, right? So something like that, you are used to some kind of brand or some features. So those are all the evaluation that you have to do based on use case or at the org level, which models that I can use. Normally, say if you have a Google Cloud, use Google Garden, all different models are available. If you want to use code generation, you want to use text, image, video, different models, everything available from Google itself. If you are on AWS, again, as I said, AWS has its own models that you can go. So I have the same thing on Amazon. If I go to Amazon Bedrock, right, and then there is something called model catalog, just like model garden in Google, it's called model catalog in Amazon AWS Bedrock. Amazon, if you see here, Nova Premier is Amazon's own model. Okay, so Amazon has these 5 models: Nova Premier, Nova Lite, Nova Micro, Nova Pro, text embeddings. There is one embedding model, and then there is Nova Pro for agents, chat optimize, code generation, reason analysis, math, multilingual support, question answering, RAG, text summarization for all of this. But we don't see any image generation or video generation here. So if that is my use case, I would not go use any Nova models in this because I don't see that. Right. So in that case, I have to go to some other any other provider here. If since I'm already in AWS and my use case needs a image generation or a video generation, I use providers which are already on the platform. Even if then, so see modality, audio, embedding, so image. If I go image, so these are all the models that are available on AWS platform that I can use for image generation. But these are not Amazon's. These are something else, stable, some other providers image generation. Okay, no, I don't want this. I want Runway ML image generation or Imagine. You can still bring those models here and then use it on this platform as well. Okay. Did I answer your question, Neeraj?
Yeah, largely yes. I just want to understand one thing here. Like, if I'm using Google Gemini 1.5, right? Then I expect that for my text generation thing, I don't need to use, or for object embedding, I don't need to use their, this image detection task foundational model, right? I can just use the top one and I'm good. Or is it like that the text or the image classification task models will perform better than the Google Gemini 1.5? I understand these task ones are like more task oriented, but the big one I expect will do everything that the task one will do.
No, this is what it's trying to do here in the task is basically it's the same thing. It's part of same 101 models. It's only categorizing them, filtering just for filtering. This image classification is again part of this 100. This is the complete models. It's showing what these models, what capabilities they have. So if I put image classification, only these models have image classification. You can use Biomed Clip, Llama 4, Claude, these models which are the image classification. Okay. So I want a video, text generation, you have 70, which means almost all of the models are capable of doing text generation. Okay. But text embeddings, we only have 13 models. So the other models cannot do text embeddings. Only these models can do text embeddings. So if you have a use case, say you want to build a RAG architecture application where you need embeddings, you have to choose one of these models to do the embeddings. You cannot use the LLM model, text generation model for embedding.
Yeah, that is clear. Okay, that helps.
Yeah. So that's how it is. Now, if you go to Claude, so that's like ChatGPT, right? Anthropic's Claude. It looks similar to this. Okay. Same application here. Now, within this, you have, see here, you can switch your models. Opus 4.1, Sonnet 4. So there are more models. Opus, Haiku, Opus. So all of these are again from Anthropic. So use any of these and then you can do the chat. Free plan, upgrade, everything is there. If you go here, again, there are some tools. So this is an application. Okay. So this is exactly what ChatGPT is. ChatGPT is application. Claude, this is a Claude desktop where you can install on your desktop. It's called Claude desktop. It has the same features. It uses underlying any of the LLM to answer your questions. You can also add that what we were talking about. These are called your tools. Okay. So for example, I was talking one of the limitations of LLM. If I use any of these LLM, okay, and so let's say I'm using this, and then I say, how is weather today in Dallas? So what do you expect? You expect it should give you the answer, right? So, but it says I don't have access to current weather data for Dallas. So I cannot tell you what the weather is like there today. My knowledge was last updated in January 2025, exactly what we talked about. So I don't have real-time weather information. So it is limited. It was limited January 2025. It was released. So its knowledge is only limited to available information up to that date. Okay. I don't have access to current weather. Then it says to get current, check weather app, visit weather.com, Dallas weather in browser, whatever. Just it's asking us to do a search. Right? Now, let's get back here. Go to ChatGPT, start a new chat, and ask the same question. How is weather today in Dallas? If you see, it immediately gives you the answer. So would you say ChatGPT is better than this Claude Anthropic?
In a
Yes?
few tasks, yes.
Okay. It's basically no, because though it is giving the information here, if you see the sources, okay, it is actually getting from the internet itself. It's not doing on its own. Okay. Same thing, but it is actually getting this information from the internet itself, because it's already, as I said, this ChatGPT application already has integrations with the tools and internet and all of that. But the underlying LLM in its raw form is this. It cannot. It's the same thing even for ChatGPT, so GPT models also. Now here, if I go, and there is something called web search. Okay. So if I click enable this web search, now it has the capability to search the internet. See, LLM is same, but now the LLM has capability. We are giving it a tool to go and search the internet. So now if I do this, say now it says searching the web. Searching the web based on current weather information. Now it gives me all of this, because the LLM model now has capability. I have enabled it, given it a tool. Hey, go and use this tool if you want to go and search internet to get the latest information. This is the same thing that is happening in the ChatGPT as well, but by default, ChatGPT already has enabled that tool where it can automatically use the resources, go to internet and search and give you all the information. Okay, so that's one of the feature limitations that we were talking about when we build agentic AI or app applications with agents. We give it the tools to the LLM model, to the agent, to connect to the resources on the internet to get information if it does not have already available information on it. And then the last thing, if you see here, these are more like your MCP servers, model context protocol. These are external services that are built. You can integrate and use it. If I want to use, say, Airbnb related here, latest information, you can get it directly using this tool. Okay. If I go here, if I enable this, question. Not this question. So I'm still using this LLM model, Sonnet 4. Okay. I want to get Airbnb listings here using this model. So this is another use case that you're building. Now this is using a MCP protocol, MCP server to get Airbnb listings. See, Claude wants to use Airbnb search from Airbnb search and listings. Do you want to allow or deny? So let's say, okay, I'm allowing it, go and use. Now it goes and uses this Airbnb search with this request and say allow again, ignore robots test setting, and then it gives you all the results for Airbnb close by here. With the budget, for the number of families, you can go view the listing, So this is one kind of use case application that you can build with MCP. Again, you have a model, you have an MCP, you click here, it gives you real time, takes you to the Airbnb.
It's actually giving the Austin, not in Prosper.
Okay. It says, I found several for your search in Austin area. The search seems to have expanded to Austin since Prosper is nearby. So it feels it's closer to Prosper based on the budget you gave it, based on the parameters that you gave it. It gave you all the nearby. So you can choose one of those. Okay. Let's say you say, hey, don't go to Austin, just give me within the specific region, it would still try and get that. So it's not that it already acknowledged that it's going to checking in the Austin area, right? So you can narrow the search just like Google. You can narrow the search, give the commands. But the point here is you can use the third party, so the connectors or apps that to connect using MCP server, MCP protocol here, enable it, and then you can use those tools like Airbnb listing, Airbnb search, these tools to do this search. So these are the capabilities. Okay. Now coming back, so we started on a journey of exploring all the models, platforms from here. Coming back to this, now tell me, are you at least have a overall understanding of what a model is, what a company or a provider is, and what an application is? Any questions? Any confusion? So we
I got
looked
a
at
question.
OpenAI, we looked at Google, we looked at Anthropic, we looked at Amazon, right? Similar Meta Grok have similar things. So these are all the companies, these are all the models that we are provided by. And your chat GPT or Claude Desktop or any other application you build or chatbots, they are all applications using these models.
Harun, I got a question.
Mhm.
What's the difference between an application and an agent in AI context?
Okay. An agent can be used within the application. So application, look at it as a use case. Okay. For any use case, you're building an application in your organization. Lead generation process is a use case. You're building an application for lead generation. Within the lead generation application, you can use multiple models. Okay. You can use agents, and then agents also use models. So agent is always a model with more capabilities.
Okay.
Again, agent in itself is a kind of a module, you can say, which will have access to some of the tools like connecting to internet or connecting to a machine learning model, connecting to a Wikipedia site, connecting to Yahoo Finance, whatever it is, it has some tools. Or you can build your own tool and give it to it. And it has a LLM model and it has some memory. All of this packaged together will become an agent. You will have multiple such agents coming together to perform the task for the lead generation. Say, for example, onboarding is one application. So you're building an onboarding AI application for onboarding. There's a new person that has come in, you want to onboard. You can have multiple agents within that application, say HR onboarding, payroll onboarding, access to the systems, access to the building, 3 or 4. So each agent has one task. Now, access to agent, access to building agent has a specific task. So what it can do, it has to raise some tickets to security, building security or whoever. Hey, this person has joined. This is his badge number. He needs to access these buildings. So it goes and creates that. It is integrated with that model, has capability to create the ticket and send it to the system that is provisioning that. the payroll related agent can take his offer letter, benefits, everything, create tickets in the HR system to provision. Another agent can take, hey, he's in analytics department, he needs access to these databases, create tickets in ServiceNow or whatever, assign to those provisioning or database DB administrators or security administrators to provide access to this person. So these are all different. Each agent can have a separate task, but all together can form one particular application called onboarding application. So onboarding is an application. Within that, each agent can have one task. Within the agent, it can use one of these LLM models.
Thank you.
Right? Okay. So LLM parameters we'll explore more tomorrow as and we go and build these topics, right? So if we say domain specific LLMs is something we want to talk about. We looked at different categories like image generation, video generation, text generation. But when we come here, domain specific LLMs are very, you can say specialist, just like LLM, if you say as a doctors, MBBS, MD kind of a thing. Then you have like surgeons, like cardiosurgeon, gynecologist, something like specialized, right? So same thing here. You will have specialized models which are taken from the basic, but trained on a specific area. Finance, for example. So this model is completely trained on finance thing. So if there is any financial agent or portfolio managers, these kind of organizations, they are not interested in asking questions to ChatGPT about weather or about politics or about the Airbnbs or the close by, right? The main focus or the use case requirement for them is about finance. So they would choose a specialized product, LLM product like Bloomberg GPT, which is created by Bloomberg, to ask finance related, to perform finance data related and sentiment analysis, question answers on this. If there is a healthcare organization who want to do research, they would use something called a MedPalm kind of models where they're trained on medical data. So it gives you a more specific answers, very clear, contextual, factual answers about the medical related questions, medical data. Right? So same thing, Kai GPT hardware. There are several companies who have taken the base models and trained it on a specific area to be more productive in those specific areas, specialized. So those are called domain specific elements. So most of these companies, if they want, they are not on the creative side or generic side, not just text will not help. They choose these specific kind of domain specific LLMs. If you want to build any application for a broker, a financial broker, you would use a specific finance related LLM. Of course, you can use combination. For research, you can use this. But when you are answering or generating a answer or generating a document, you can use generic like GPT model also. So both together, you can use one for research, one for consolidating your research and generating a document or generating an answer. 2 or 3 models kind of thing. That's why you have one agent doing a specific task, one agent do the research, one agent do analysis, one agent just summarize all of that in a format, and then provide an answer to the customer. Okay. So these are the components that we will be talking about. LLMs, we talked about embeddings, we'll talk next week, vector databases, what is RAG, what is agents, how to build agentic applications, all of that. So we'll take this forward tomorrow about what are the basic architectures, and then we'll be exploring starting next week. So tomorrow we'll talk about what are the basic architectures, components of generative AI. Okay.
Arun, is same time tomorrow?
Yeah, same time. Every week, same time, 7:30. So before we wrap up, any other questions, anybody?
Harun, I got one more question. Are multimodal, basically, are multimodals more prone to hallucinations?
In general, that is very subjective. It depends on the model. We can't just say multimodals hallucinate more. It's more like sources that you can ask, to quote the sources to reduce the hallucination. But it's more of a provider or model specific, how good the training is, or more how best the guardrails have been implemented within that model to not to hallucinate. There are some levers to reduce the hallucination, like you increase the temperature or you request the citations, you have very specific system instructions, and then you have very specific guardrails. So based on all of that, you handle the hallucination, but you cannot generalize saying multimodals are more prone to hallucination than the single model. Yes, it might be because the more the complexity, the more scope for hallucination. If you have domain specific, it will be less prone to hallucination because they are only trained on a specific data and they only answer based on a specific criteria or a domain. Whereas if you take a bigger model like GPT-5, it has huge canvas, right? Huge information to read and respond from. So as it processes more information, wide variety of information, yes, more prone to hallucination, kind of.
Okay, thank you.
All right, guys, thank you so much. I hope that was informative. Yes, this today and tomorrow, as I said, it will be more foundation. We will actually get into hands-on code starting next week. So tomorrow we'll talk some of these architectures at high level. We don't go deeper. We'll explore in the coming sessions, but all of these we'll explore at high level. What this architecture, why this architecture, what problems they solve, and then we'll talk about prompt engineering tomorrow. What are the different techniques of prompt engineering? So this week you'll have solid foundation, and we'll be ready to go starting next week with building the embeddings and vector databases. Okay, so do let me know. Give me and I have one more thing: the recordings and the decks will be shared, but it takes 24 to 48 hours to process and upload. So be patient. By Monday, you should have all the information, recordings, decks, code. If there is anything, everything will be shared by Monday every week. Okay, and generally the link for the class will also be provided by a day before. So don't worry, even if it's get delayed, unless specifically it is mentioned there is no class, it's standard 7:30 Saturday and Sunday, 7:30 a.m. CST, which is 6 p.m. IST. Okay, I'll make sure you get in advance the link for the session, because each session there will be a different Zoom link. And again, if you have any questions, if you're not able to answer here, you can post it in the group, or you can send it directly to me, post it to me. I'll be happy to answer, or we can take it up in the next session to discuss. Okay, all right, thank you so much. Do send me your feedback, both from the pace of the training. Is it good, too fast, too slow? The mode of training, communication. Though this is only one session, you'll get more and more when we keep moving forward. But yeah, I'll welcome all the feedback, and then I can change the delivery model based on the feedback.
Thank you so much, Harun.
Thank you.
All right, guys. Thank you so much. Appreciate it. See you tomorrow.
Thank you. Bye.
Thank you. See you later.
Thank you. Thank you, Aaron. Bye-bye.
Bye.